The next physical quantity to describe the motion is displacement. Everyone think that distance and displacement are seems to be same pronouncement, so that's why these two are same, but not. Distance and displacement both are different to each other. Only in few cases, not only few cases, only in one case, the magnitude of distance and displacement are same. Before going to discuss about that, what is the nature of this displacement? How can we define the displacement covered by the body? It is like this. In the previous example, if you took the previous example, initial position is A, final position is B. This straight line is the actual path to follow the body. Yes, if these 2 points are joined together on a straight line on either ends, sometimes one point will be like this and another point will be like this and another point will be like this. If this is the case, a person wants to move from A to B, again from B to C. If it is from A to B and B to C, then what we can understand is he has to move from A to B. Then he took the diversion from B to C. Yes, it took a long length simply. But what is the shortcut from A to C? Yes, it is a direct route. Let us suppose this is some 6 meters, this is some 8 meters. This will not be in between the 6 and 8. So, how it will be look like? This AB plus BC, it is distance. But if you draw a straight line directly from A to C, this is shortcut. But the people are always chooses the shortcut to reach a long destination. If it is a perfect shortcut, they will choose that only because it reduces the time of journey, it reduces the work to do the journey. So that's why always the human beings prefer the shortcut to reach a destination. So this shortcut in scientific words is called displacement. So what is displacement? The physical definition of the displacement is the shortest distance between initial position to final position with respect to time. So time is very, very important. Means while we are measuring the distance or displacement, time difference is automatically there, because if it is a short distance, it will take short time interval. If it is a long distance, it will take a long time interval. So the shortest distance between the initial position to final position is called displacement of the body. So displacement is always a shortcut to reach the final destination. Only in the straight line motion or rectilinear motion, magnitude of distance is equal to magnitude of displacement. In rectilinear motion, magnitude of displacement is equal to magnitude of distance. Now we will see the clear differences between the distance and displacement with the help of mathematical proofs. So displacement is a vector. A vector physical quantity means both has magnitude as well as direction. magnitude as well as direction. This displacement is how different to distance. We will see some examples, then you can understand. Let us take a body. One example, first example. It was travelled from A to D in a straight line path. Meanwhile, 2 points are there. We can compare this one like a bus is traveling from one point to another point by crossing all the halts. This B and C are almost similar to the halting points of the bus. So let us suppose from position A to position D, the body has covered 300 meters, let us suppose. So we can say A to B is 100 meters. B to C is 100 meters, C to D is 100 meters. So we are taking round figures for our easy calculation. So what is the distance travelled by the body? Distance travelled by the body is equal to AB plus BC plus CD. Yes, 100 plus 100 plus 100 meters is equal to 300 meters. Because we are keep on adding the distances or lengths covered by the body in the given prescribed path. What about the displacement? Displacement, how can you define the displacement? Shortcut. But in a straight line there is no shortcut. But we can say landmark at final position minus landmark at initial position. So this is the landmark from A to B, B to C, C to D. A is the initial position. D is the final position. Automatically, if A is at 0th mark, D will be at 300th mark. So the landmark at final position is 300. Landmark at initial position is 0. So automatically the value is 300 meters. From this example, we can understand that if a body keep on moving in a rectilinear path or straight line motion, then in straight line or unidirection, then magnitude of distance and displacement are same. This is called unidirection. Once the direction changes from D to another way, then this example will give the another result. So only in the straight line motion or unidirectional motion, distance magnitude is equal to displacement magnitude. The next example, the same diagram we are taking, A to B, B to C, C to D. As we know, the distance from A to D is 300 meters. Means, yes, this is 100, this is 100, this is 100. AB is equal to BC is equal to CD is equal to 100 meters. So what is the difference between the distance and displacement? Let us suppose a body has travelled from A to D by crossing the points B and C. From here onwards, it was moved back to C. Means it has reached the destination D. After finishing the work, it was moved to C in the reverse direction. In this case, we should find out the distance and displacement. So we know that distance is equal to, what is the actual path length followed by the body? A to D first, then from D to C. So A to D, from D to C. We know that AD is equal to 300. The distance from D to C is 100. This is 400 meters. But try to find out the displacement for the same situation. So what is the meaning of displacement? Shortcut. Anyway, the body was initially traveled from A to D, then it reached to C from D. Shortcut means no need to see the total coverage. Body has started A, anyway it was ended its journey at C. So what is the shortcut from A to C? AB plus BC. 100 plus 100 is equal to 200 meters. In another way we can prove the same. Yes, displacement is equal to, yes, initially AD is the path. Once the direction changes, because displacement is a vector physical quantity, once it changes the direction of motion, we should represent with the opposite sign in nature. So that's why AD plus of minus DC. Because AD and DC are opposite to each other. So AD 300 plus minus, what is DC? 100. So it is 300 minus 100, 200 meters. Now we got the difference. Distance is the actual coverage of the body in any path. Displacement, shortcut of the body from initial position to final position. We will see one more example to find the differences. This is one position. This is the another position exactly in the opposite corner, like a room. Three persons have started motion from this position A to reach this corner point. Those three choose the three different paths. One chose this path, another one chose this path, third one chose this path, like this. So if you want to see clearly, this is A, this is C, A to B and B to C. This is one path. A to D and D to C is another path. And directly from A to C is the another path. This is path 1, this is path 2, this is path 3. Path 1, AB plus BC. Path 2, AD plus DC. Path 3, directly AC. No turnings. In our common sense, we can say that the way from A to C is the shortcut to reach the destination. But three students followed the three different paths. Let us write the values. A to B is some 8 centimeters. B to C is 8 centimeters or 8 meters we can say. B to C is some 6 meters. It occupied the shape of a rectangle, that's why A to D also 6 meters and D to C also 8 meters. If you want to find out the distance traveled by the body, this path 1 and path 2 are the examples of distance. So AB 8, BC 6, 14 meters. Again the path 2, AD plus DC, 6 plus 8 meters, it is nothing but 14 meters. So what about the path 3, AC, this one? So if you consider this ABC is a right angle triangle and ADC is also a right angle triangle, AC is the common hypotenuse to the both triangles. So if you find the length of this hypotenuse, that will be the distance from A to C, which gives the shortcut or the displacement of the body. For this purpose, we should use the Pythagoras theorem. So from Pythagoras theorem, hypotenuse square is equal to side square plus side square. So what is this hypotenuse? AC square is equal to, if you see the triangle ABC, it is AB square plus BC square. In another way, for the another path, hypotenuse square is equal to side square plus side square. Again AC is the common. Side square plus side square means AD square plus DC square. As we know the measurements of these, what is AB? 8 square, 8 meter square. BC 6 square. Here also it is 6 square plus 8 square. 8 square 64, 6 square 36 is equal to AC square. So here also AC square is equal to 36 plus 64. Anyway, we will get AC square is equal to 100 meters. This AC square is also equal to 100 meters. AC square is 100 meters. What about AC? Therefore, AC is equal to square root of 100, nothing but 10 meters. So this A to C is 10 meters. See, AB plus BC, nothing but the distance covered by the body is 14, as well as AD plus DC, distance covered by the body is also 14, but the shortcut from A to C is simply 10, means it is less than 4 meters of the remaining paths which are representing the distance covered by the body. Now we can say that this AC is the shortcut, and we have proved this mathematically by using the Pythagoras theorem. Like this, we can separate, or we can show the differences between distance and displacement.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.